Hello, everybody. Welcome to the 2022 Charged Up Preseason Panels. We are incredibly excited for a week of virtual workshops covering everything FRC, and we hope this is an educational experience for everyone. Now let's get started with our first presenter from Team 5199 covering the topic of simple solutions for FRC success. Please leave any questions or comments in the stream chat, and we will address them at the end of the panel. Take it away, Teddy.
Alrighty, so this is simplifying FRC. And so a little bit of an introduction. I'm Teddy Bullicus. I'm a design, manufacturing, scouting, and strategy alumni mentor of 5199, Robot Dolphins from Outer Space. I'm currently a mechanical engineering major at San Jose State University, and I have over 6 years of FRC experience. So first off is probably the question on everyone's mind. What do I mean by simplifying FRC? And so the biggest thing I mean by that is KISS. And, that is most commonly referred to as keep it simple, silly. There's other variations, all with the same message. And it's pretty much saying that, you don't want to do too much with too little. There's a line between, keeping it simple and going over the top. And so when it comes to FRC, simple solutions and easy solutions are definitely an effective strategy when going about designing and building your robot. Because, you don't always have to reinvent the wheel to make the wheel. You can go back and look at past year's games, past year's robots, or just go to a competition and be like, hey, that team did something that I liked. I could do that too. And then you automatically have to do less, and you're keeping it simple for yourselves and your team. So a popular engineering principle is the 90% solution. And so when it comes to an engineering problem, there's kind of what you would call a solution curve, in that when you first start off with a problem and you're doing your initial steps of, brainstorming, prototyping, you're going to make a lot of progress very quickly. And it's going to be exponential in the more that you do, the more and more clear your solution is going to be and the more effective it's going to be. Think of, if you're going to be making an elevator, trying to get the tubes lined up and the linear motion going is going to make a world of improvement from when you first start to when you actually get it going up and down. But the farther along in the process you get, the more refined your solution is, the less of a jump it's going to be. When you've spent, 100 hours versus 102 hours on a subsystem, there's going to be less difference between the two versus hour 0 and hour 2 of a subsystem. And so when it comes to FRC, there's the 90% solutions and then the 100% solutions. And so when it comes to 90% solutions, those are usually to go and have a 90% solution subsystem. They're going to be a little bit more simpler. They're not necessarily going to be as effective, but they're going to be easier to maintain. Whereas 100% solutions are going to be more time intensive to get it all the way to where you want it. They're going to be a little bit more effective, but they're also going to be more complex. And so to make sure everyone really is captivating what a 90% solution is say you want a shooter, right? 100% solution would be anywhere on the field, the 27 by 54 foot field. Your 100% solution would be, I could shoot from wherever on the field I want. A 90% solution is maybe I could shoot from all but maybe the back corner. I can shoot from, 85, 90% of where I want to shoot from. And that's a slightly simpler solution to the same problem. But by making it slightly simpler and not going over the top, doing 100% of the goal, it makes it easier to accomplish. So the next key to keeping it simple in FRC is robustness. There's a heavily quoted best ability is availability. And, it's pretty self-explanatory that, if your robot can't be out on the field for the game, then there's no real point in having a robot. So it's better to have, a robot working 50% efficiently 100% of the time than 100% efficiently 50% of the time. Because especially with the new format of playoffs, that have been demoed this offseason and are currently, for all intents and purposes, planned on using going forward. You have one match with your alliance in the playoffs, where if you don't perform, you're in the lower bracket. And for that, if you're 50% off, hit or miss, if you miss, you're down in a hole versus if you're always being consistent. So what does it mean necessarily to make a robust robot? It means make it simple, because simple is easy to maintain. And as all the old trailers for FRC games used to say, make sure your robots are robust. That means, contact with other robots and game pieces. If your robot gets one tap and then is out of commission for the rest of the match, it's not going to be as effective in games with heavy defense versus robots that can get grounded and pounded and still operate, because they're well built and easily maintained to where if something does break, it's not a 10-hour fix, it's a 5-minute fix. So you're able to be ready to go for the next match. So a common simple solution that has come up in the last couple of years is the Everybot. And so the Everybot is devised by Team 118 out of Texas, Robonauts, who have a pedigree for these complex mechanisms robots that, have won a lot of events, and they've been world champions multiple times. And so starting back, I believe it was 2017 or 2018, they started this concept of Everybot. And, it's roughly 1,000 for bill of materials, and they release about 2 weeks into the season bill of materials and CAD for this simple robot. And to quote the website, it's an affordable, competitive, simple robot. And as you can see, there's the 2019 or 2020 and then 2021 or 2022 Everybots. And so the goal of the Everybot isn't, to be able to do everything. It's a concept for every team to have a robot that can at least do the essentials. And so by essentials, it means drive around and be able to help and contribute to an alliance. So when it comes to the most recent Rapid React one on the top, it was able to score into the lower goal, and it was able to climb to the mid bar. And, that contributes points multiple ways in the alliance. I can drive around, so if everything else fails, it could play defense. In the 2020 version, it could drive around, it could hang on the hanger bar, and it could also score in the lower port with the power cells. And again, it's a different way and approach that most teams take, but it's still a way to help an alliance by being able to score points. And so another evolution is the robot in 3 days. Robot in 3 days has been around for a slightly longer time, originally originating in 2016, I believe. And so the robot in 3 days is, as the name would imply, streamed for 72 hours after kickoff. And so these teams, the core goal is to inspire and prototype ideas for other teams. Most of the time, these teams are comprised of experienced FRC alumni and mentors who are more ready to do rapid prototyping and produce the robots, as you can see in the picture, for that year's game. So the standard weekend of kickoff starts, 9 a.m. Pacific Standard Time, usually roundabouts, different for the different time zones. But then the robot in 3 days spends that first couple hours afterwards creating the strategy of what they're going to accomplish with the robot, and then the remainder of the time they prototype and build it, and usually live stream it for all the FRC teams to see. This is really good because the fact that it's putting it out there for everyone to see, similar to the Open Alliance, which was started back in 2020, it gives a foundation set of knowledge for everyone to use and access based off of rapid prototyping. And people who are doing robot in 3 days aren't newbies who it's their first robot. So they have experience in what works and what doesn't, and they're able to share that knowledge with teams. So when it comes to design, there's a couple of different ways to keep it simple. And the first is for the scope of your team. The number one thing that teams do, especially when they're newer teams, is they try to overextend themselves. And, to keep it simple, you just don't overextend yourself. New teams, old teams, smaller teams, bigger teams, they all have different types of capabilities. And in general, a finished simple robot is better than a half-done complex robot. Because if you have a complex robot, with the latest swerve drive, but you can't drive it, you're going to get beat out by a simple kit-bought chassis that can drive around. And so the scope that you define, which can be easily done before kickoff, is a huge part of setting the standards and what you want a robot to look like going into the season. Secondly is the different challenges in games. There are different ways to score in every single game. There's never ever one single way to score. This is every single year a way for FIRST to try and cater for new teams as well as old teams and keep the game interesting for all different levels of experience in FRC. This is exemplified wherein games like 2022, there is an upper hub or goal that was worth more points. There's also a lower goal for newer teams to have an easier time scoring. Back in 2018, as shown in the picture, there was a vault and an exchange in which all your robot had to do was drive around in order to put power cubes or milk crates, which were the game pieces that year, into the to score points through that hole. Your robot literally could drive and do nothing else and still score points for your alliance. That is a huge type of shift for lower end teams who maybe don't have the capabilities to build an elevator early on. That's perfectly fine. There are multiple ways to score. If your robot can't do everything, you should still be intentional with what your robot can do. Because if you set your sights for the moon, as the saying goes, set your sights for the moon, at least you'll end up with the stars. However, if you set your sights on the stars and you end up in the stars, that's a lot better because you at least intended to end up where you wanted to go in the end. So if you're intentional, and there were robots back in 2018 who, prioritized keeping it for the low for the switch, which was the lower goal, and the exchange. Robots that intentionally set out to do that were worlds better than teams who tried and failed for the high goal, for the high scale, and couldn't quite get it. Similarly, in most recent years in the 2020 Infinite Recharge, 2022 Rapid React, there were ways in which alliances could be helped by scoring in the low goals or the low power ports, when there were ranking points being assigned based off the volume of balls being scored, not necessarily points corresponding to it. So a ball that was scored in the lower port in 2020 was only worth 1 point, where it could be worth 2 or 3 in the inner or outer upper port. However, the ranking point was contingent on how many balls you scored, not the points from it. So if a lower end team built a really effective low scoring robot that could score 20 low goal balls, they were able to successfully help their alliance to the ranking point much more than 5 points in the upper. Next is simplifications in scouting. So the first major questions are why and how you scout. So why you scout is that way you're collecting data for your team's decision making. That is why you scout in FRC. You want to collect data so that way you can make informed decisions. Pick lists, match strategy, and your general ranking of teams and robots for who's good at certain tasks is why you collect data. You do that because otherwise you're looking at a sheet of teams and you're not really able to suss out what is what. And going based off of solely the rankings at an event or other statistics on Blue Alliance aren't as useful as your own data, because while the event might have teams ranked a certain way, you might think of other teams as being, having an easy schedule or having a hard schedule, because diamond in the rough teams are a lot easier to identify when you scout your own way and not just rely on statistics provided to you. So that brings us to how you scout. And so there are different ways that you can go about doing it, but you don't always need a specific programmed app to scout. You can do it many different ways. That's one way that higher end teams with a lot of programming power choose to do it. Our team used paper for years, with a sheet of paper for a match, and you would record things with pen and paper. We converted recently within the last 3-4 years, using Google Forms. So it's easier to keep track of all the statistics at a single glance. And when you use Google Forms, you're able to just type in your answers as the match goes along. So the next question for scouting is what you collect data on, because now that we've recognized that you should collect data, the question is what you collect data on. And so what you collect data on comes down most importantly to what you make decisions on. If you make decisions solely based off of how fast a robot is, you're going to need to collect data on how fast a robot is. If you're collecting data because you want to know how many balls a robot can score, it may not be as meaningful to you how fast a robot is. So only collecting data on how fast a robot is when you're making a decision on how much your robot can score, it's collecting data on oranges when you want to eat apples. And so it's hard to pick the best apple for you to eat when all you have is data on oranges. Our general rule of thumb is you want to collect data on everything that adds points to the score for an alliance. That means that you want to have allocated ways to keep track of scoring game pieces and any other game tasks in which you can score points, most recently denoted through climbing, through the hangar, through other climbing end game tasks. Also, a way to not necessarily add points to an alliance score, but to remove them via defense is also a credible thing to keep track of if that's the type of thing that you want to look for, especially when it comes to the third and fourth members of your alliance. An additional thing that we add to when collecting data is probably one of the more simpler things to keep track of, and it's the eye test. When you're watching a match of 6 robots, it's very easy to compare one robot to another because there's 6 on the field, and so you can do large sample size process of elimination. It's pretty easy when watching a match to tell who the fastest robot on the field, and likewise the slowest robot on the field, who's scoring the most in the match, who's scoring the least. So there's a lot of easy ways to get data to say, okay, I have very limited scouting capabilities because my scouting team is 3 people, so we can't watch every robot every match. You're still able to say, hey, I know these teams are putting up a lot of scoring, and these teams are slow and are pretty much sitting dead the whole match. That at least starts stratifying teams into can score and can move fast, or can score but move slowly, and going down the line with simple yes/no rankings based off of the 6 robots in a given match that you're watching. So lastly, we're going to take a look at successful team examples for teams that keep it simple at a high level. The first team is Team 973 out of Tuscadero, California, the Greybots. And so they keep it simple with having West Coast Drive every year and having simple solutions for how they complete game tasks. They don't always have to do everything, but they're effective with what they do. The robots shown in this picture are their 2022 Rapid React robot, their 2020 Infinite Recharge Robot, and the 2019 Deep Space Robot. In 2019, if you're unfamiliar with the game, there was a rocket on the side of the field where you could score game pieces on 3 different levels. However, the Greybots knew that they couldn't allocate and build a perfect robot that could score on all 3 levels and be effective as they wanted. So their robot only scored on the bottom 2. So they were leaving points that potentially they couldn't score during a match, but their robot was efficient enough that it didn't matter because they were able to score points quicker than they would have been able to had they been scoring on all 3 levels. Similarly, their 2020 robot was very robust and simple in that it just picked up power cells into a giant hopper and then fed them into their shooter that shot quickly. So they would just spend the whole match going back and forth, just picking up balls wherever they could and just driving. They didn't worry about going under the color wheel or making their robot more compact. It was big and it was good at what it was able to do. Similarly, in this past year for Rapid React, Greybots had one of 2 robots on Einstein that were West Coast Drive that weren't swerved because they know that they're good at it. They kept doing it. And what did they do? They added in comparable things to make up for their weaknesses in adding a turret. But they didn't even have a full traversal climber. They only climbed to the high bar, which most teams, tried to go for the traversal, but similar to Greybot's fashion, they were efficient in what they were able to do. And knowing that they couldn't build for everything, decided to just make an efficient high climber and say that was a 90% solution to the task of trying to get as many points as you can, as quickly as you can when it came to the end game and the climber. The next team is 2910 Jack in the Bot out of the PNW in Washington. The stereotypical Jack in the Bot robot is a small swerve drive robot that utilizes mecanum wheels and pretty simple game piece pathing in order to get as many pieces as they can up in scoring, and that's why they're one of the powerhouses in PNW. If you look at their robots over the past couple of full seasons, going back to starting at their appearance on Einstein in 2019, in Destination Deep Space, where again there was a rocket with 3 different heights. They didn't even go for the middle. They just solely went for the bottom. As you can see in the upper right-hand corner, their robot was only able to score low with a hatch panel mechanism that was always at the same height. In addition, cargo ball scoring that was a single pivoted joint. They didn't go all out and say, we have to do everything. They said, okay, we can't do everything. So what is the most efficient use of our time? And they decided on a simple robot that was able to only score in the lower parts of the game field, like the Everybot that year. However, they were able to do it effectively because they intentionally set out with their goals to do that. Similarly, in 2020, this past year, their robot could hold 2 balls and had an extremely small footprint. That allowed them to move around the field, whereas bigger, more complex robots maybe had a harder time fitting in between other robots. Their small, simple, sleek design was able to maneuver much, much better. And the more complex parts of their robot is probably their patented swerve drive that they use. In fact, they're the team that runs swerve drive specialties, which is the most used commercial off-the-shelf swerve drive, which is another key thing that it can be shown off by these high-level teams who are consistently trying to keep it simple. They use commercial off-the-shelf parts. COTS parts are one of the best ways for teams to elevate their game with a limited base. If you go on West Coast Products, there's a whole page just for, swerve drives and elevators and shooters and turrets. And they make it super simple for you to essentially buy a mechanism, slap it on your robot, and have very limited amounts of trial and error, because it's tried and true parts and mechanisms that they're availing to, and making it a wider FRC audience being able to do certain tasks. Back when elevators were the first in games in 2007, it was a struggle for a lot of teams to do and execute. But as the more they've come up, the more teams have gotten better at it. Look at 2016, for example, when climbing on a rung was the first time in an endgame challenge. There are very few teams who are in the Houston or in the championships at that time in St. Louis who could climb. Now, fast forward to 2022, in which there was a wide percentage of teams who could go and climb monkey bars on rungs, and there is very few teams who couldn't get on a bar at all. The more that challenges come up and the more that teams are able to utilize past designs and commercial mechanisms and subsystems, the easier it is and the more simple it is for teams to compete at a high level. Thirdly, the team that keeps it pretty simple is Citrus Circuits. They're one of the teams that iterate on simple ideas to make more complex robots, and they're very consistent in what they do. All of these three of these teams, it's very hard to find matches in any competition in which they're not performing at a high level. That's because they're making robust robots that have had a lot of testing, so that way they're ready to go and compete. In 2022, this past year, the Citrus Circuits made 5 robots before their 5th one being the one that they competed with. They made the most simple robot within a week that they were then able to iterate on and improve and refine. That means, most teams aren't at the position that they're at with, 100 plus members and a lot of machining capabilities. But the general idea of, hey, let's make a robot and then learn from it is a very applicable idea. Looking at their past robots, back in 2015, when they won the World Championships, they were trying to build a robot, and if you're not familiar with the Recycle Rush game, you could hold up to 6 totes tall, and there's trash cans that you placed on top. You would be able to score more points. However, with their calculations, they're able to decipher that the points for the trash cans on top didn't outweigh having the amount of 6 totes underneath it. What I mean by this is, based off of the height limitations, it was only a couple of inches to deal and maintain a trash can on top of 6 totes, whereas versus 5 totes, you had a lot more room to work with. And based off of their design, they were able to go and build a very competitive robot that can only stack 5 totes high, whereas all the other teams that year were stacking 6 totes high. And this acknowledgement of being able to make a simpler way to control the trash can on top allowed them to win it all that year. So as a lasting response to make as one thing to take away from this, you can always apply keep it simple to every aspect of FRC, whether it's scouting or your design process. There's always a way that you can simplify and remove variables from your equation to make more robust and easier to use solutions. So, are there any questions in the chat?
All right, thank you for that presentation, Teddy. We do have some questions. Firstly, do you think teams should focus on making a great defense bot over scoring if they are going to have limited success designing and engineering more complex scoring challenges?
I think that when it comes to defense robots, there are a few core, I'll say, components of it. First of all it's being able to drive and drive well. That means making a robust drive base that, is almost the fundamental of a robot. It has to be able to move in order to compete on a big field. And so having a robust drive base is going to be the same no matter if you have the best robot or the worst robot at a competition. Secondly, what makes a good defensive robot is practice. And again, that does not matter whether you have a really good robot or a really bad robot. You should still practice as much as you can with your robot to where you're going to an event, not testing everything for the first time, and it's your first time ever touching the controller and operating the robot. So to answer the question of whether you should go and devote to just a defensive robot solely versus trying to go and score, most of the time, a good defensive robot, it's not about designing a robot for defense. A good defensive robot is a robot that is well-driven, that can drive, and that can be any robot. So it's easier for you to go and try and score and be more of a contributor to your alliance, because a robot that can just drive around, that's driven really well, is even better if it can drive around really well and can also climb, or can also score during auto, or hold 2 balls if it was 2022.
All right, thank you. Next question up is how do you effectively decide what you should and should not design your robot to do?
An effective design in deciding what you should and should not do comes down to your team's capabilities. If your team is a 20-year veteran team and all your students, or a large majority of your students, are 4 or 5 year veterans of FRC, they've been doing it for years, and all your mentors have experienced, you're obviously going to be able to fight off a little bit more of the challenge, come up with more complex solutions. Whereas if you're a rookie team and no one has any FRC experience, you've seen other teams compete, but you've never really competed yourselves, and your mentors are there to support the students, you obviously can, you're not going to be able to advance as far, no matter how advanced engineering wise you are with your mentor's help. FRC, you don't know how to do it well until you've tried it. So in that case, it comes down to what you're evaluating your team. I said, when it came to the scope of your team before the season starts, taking a look around to your left, to your right, and being like, okay, our team, probably isn't the best in the world. So maybe we can't do everything. So when we evaluate the game come January, we should say, okay, there are some easier tasks, there are some more advanced tasks. We'll start with the easier tasks, and if we're able to handle those pretty easily, we can try taking off and doing a little bit more, instead of saying, we're an average team, but we're going to try and do everything and be the best robot out there. Because in reality, there's only a couple robots, a couple teams who can consistently perform and be the best robot out in the field every event.
All right. And then given that you can build until the end of the season, is it better to deploy a simple bot at the beginning of the season or at the end of the season?
I'm going to modify the question and say, is it better to have a simple robot in the beginning and iterate, or just have, the same robot throughout? Because for me, that makes a little bit more sense. But if it doesn't answer the question fully, feel free to rephrase it, because that's kind of the gist I'm getting out of it. And it depends on the work ethic of the team in which you're on. Back in 2016, Team 21-22, Team Tater, is very famed for iterating throughout the season. As their first event, there was a low goal and there was a high goal that year. For their first event, they came in just a low goal shooter. Their next event, they were a low goal shooter and they could also climb in the end. And then by the time they got to champs, they had a high goal shooter and could climb. And so if you have a team that's committed and willing to spend the long hours for an extended period of time, you can start off simple and continue to iterate throughout. And, if there's a more complex task, continue to work on it the whole time and put it on your robot later in the season and start off with a simpler one. In parallel to that, if your team, is only a couple of people to where you'd be taxing 4 people for 4 months, it's not going to be as an effective a strategy to start off with a simple robot and go back to each subsystem and make it better. In that case, it's probably better to make an average robot and spend time refining it and having time with it than trying to make a simple robot, refine it, and go back and make a more complex robot that's better and refining that as well.
All right. And then another question. Do you think it is worth to try something like Swerve for a team that has not attempted it before? Or in other words, is it worth the risk for the higher reward? Kind of answered this earlier, but
I think it comes down to where your team is at. If your team has, we'll say, a general grasp of the West Coast drive system, and you can build it and drive it effectively, then your team is probably pretty well endowed in FRC. If your team is a rookie team and doesn't have a full grasp of the West Coast drive, going and advancing to a Swerve drive and trying to learn the more complex system out of the gate is probably not the move. If your team is more advanced and has the grasp, then you can more easily make the transfer because you already know and can apply what you learned about the West Coast drive in making sure that your tolerances are in line and what parts of a drivetrain can wear down more easily, whether you're using chain or belts, and the type of programming capabilities responsible, and the driving responsible, because the amount of time you have to spend in learning how to drive your robot will vary based off your drivetrain. And it's a lot easier for less experienced people to do a tank drive with joysticks, because that's most similar to what people do on a more daily basis with video games and the like, in having a left side and a right side, whereas a Swerve drive is more expansive in that you have a direction and you also have to turn, and they're not the same because there's not always the same left, right, front, and back.
And then what's the best balance of test and design?
When you say test and design, is that the extent of the question, or is there?
Yeah, that's what I've got here. I believe they're talking about like designing and then testing after for the robot. So
I would say that the biggest thing is doing a lot of tests in the beginning to then design around, because you could, when it comes to the season, back when there was only 6 weeks and then a bag day, if you spent 3 weeks designing and then you tested it out and realized, oh, wait, none of this works, no part of the design works whatsoever, then you're going to be in trouble. Versus if you spend 3 weeks testing and doing prototyping and then go and do design, you're going to be, that design after 3 weeks is going to be a lot more reliable because you're able to eliminate variables. So say this past 2022 season, your team went and wanted to make a shooter for the high goal. There's a lot of different variables that can come into play. For example, the cargo was a 9.5-inch sphere, which is very large. So the amount of compression on it and the amount of RPMs on your shooter wheel, and then having backspin wheels, how many backspin wheels? All of these are different questions that you can refine and get answers to during prototyping. Like, which is better, 7-inch or 1 inch of compression or 1.5 inches compression? If you prototype it and can definitively say, okay, this compression is the best for shooting the ball, and when you design it, you don't need to be like, I'm going to design it for this much compression, but it could not be the best ideal number. You're able to establish more concrete numbers and have to do less changing in the design the farther along your testing goes in the beginning.
Right. And then, is it worth designing your own subsystems if there are COTS items which do the same thing?
It depends on the case, I would say. There's certain mechanisms like a swerve drive that have been, I'll say, mainstreamed recently, in where before about 3-4 years ago, back before Swerve Drive Specialties was selling them and West Coast Products was selling them, it was a lot harder to build your own swerve drive and make an actual decent swerve drive, and that's why very few teams did it. Versus nowadays, you could go and you can buy them, and it's not super hard to implement them. Likewise, there's more and more COTS being available to teams. It seems like almost every 6 months to a year, West Coast Products is releasing a new COTS items to help teams get and advance their robots. And so if you're a mid-level team, it's a good solution because maybe you don't have any experience building an elevator before because your team is, 3 or 4 years old, and back there's never been an elevator game to where you needed to do it. Then it becomes a really good idea. When your team has built elevators before, for example, then you can look at them and say, when we build our own, we like it just the same or possibly even better than this simplified version of an elevator that's part of COTS. And so in that case, if you already have a solution that's mapped out and you have on record, it's not that big of a reason to just turn and go to COTS items. Because if you can build a shooter that shoots really well, and you're able to build well because you've been doing it and you know what you like in a shooter, you don't necessarily need to go buy a standard, I'll say, more vanilla shooter when you have a more custom one that you prefer.
Okay, and then another question. What do you think is the most effective way to organize ideas a team has when designing a robot based on simplicity and then based on complexity? What criteria would be used?
Could you repeat the question, please?
What do you think is the most effective way to organize ideas a team has when designing a robot based on simplicity and complexity, and what criteria would be used?
So I think the best way to kind of go and for the design process and just kind of sounds like prioritize the list based off of the different ideas. I would say going subsystem by subsystem for the robot, and I would go starting with the most crucial after the drive phase, because the drive phase, it's pretty, there's not a lot of options for any given year, and year to year, it's going to be pretty similar in that you're either swerve drive or West Coast drive. Those are the two main options. Not many teams will go for a butterfly or an H drive or anything like that. So it's either swerve or West Coast, and then from there, how many wheels or what type. And those are always going to carry over year to year, and your team can have a preference on that. Versus each year's game will present a different challenge, whether it be shooting, whether it be some form of elevator, or a different object like a frisbee rather than a sphere. Those types of scoring mechanisms go at the top of the priority list in terms of subsystems. And then once you're there, I would rank it from the most or the least complex that effectively scores how you want to the most complex, and then inversely, the most efficient, the least efficient. Because if you have a design that is super duper simple, but 50% efficiency, and then it goes down the list, and at the bottom of the list is, super duper, scores every single time, but it's super duper complex. But then you have, that's not going to be as good as if you go and you have, something that is super efficient for what it is. So trying to find the balance between the two of complexity and efficiency, where efficiency, and what I mean by that is efficiency in completing the task. If you have a climber that works 100% of the time, it takes 2 minutes to climb, versus a climber that works 50% of the time, but you can do it in 10 seconds, you would probably rank the one that can do it in 10 seconds higher, and then trying to improve the likelihood that it succeeds, rather than starting off with 100% efficient and trying to reduce, 300% of the time off of it. And then what was the second part of the question?
Just what criteria would be used?
Okay. Yeah. So I kind of answered it, but to restate the criteria, I would say looking at your robot, your subsystem by subsystem, ranking the scoring challenges to most crucial to least crucial. For example, the 2020 game with the color wheel, that operating that and selecting a specific slice of the pie, probably the bottom of almost every team's list, because it's circumstantial and you don't need it to win.
All right, we got a specific question. So how can we make bumpers simpler? Are there any tricks to making it an easy build?
Bumpers are a very thought out part of FRC, in that in the game manual each year, there's always specific sections and rules on them. And year to year, they're pretty standard in that you need 1.5 or 2.5 inch pool noodles for a 5-inch height bumper, and then it needs to be a certain amount of space. I believe it's 6 inches or so from every corner, and it's all to adequately protect your robot from other robots, protect other things from your robot. And so there's a certain simplicity in that you can just duct tape pool noodles to pieces of wood and bolt it onto a robot. Or there are other teams, I'm going to go back a couple slides, in 2019 or 2910, as you can see from their robots, what they do is they actually attach it to tubing and machine plates, to where it's a lot easier for them to attach it to their robot. Most teams don't always do that. Our team for a long time used clips where there would be a hole in the side of the robot, and it would go in and it would clamp, and that's how we secure our bumpers. And so just 2 latches, and that's how we secured each side of our bumpers. So there's a lot of different ways to do it, and it comes down to, when you say simple, it's really a matter of the bumpers are there to protect your robot, protect other people from your robot. So what is the most, because it's not going to be the thing that makes or breaks game for you. You just have to make sure that they stay on the robot, because a robot with only half a bumper, because the other half is lying on the field, it's going to get disabled for safety concerns. So just making sure that it's staying together, doesn't tear apart under contact, is really the simplest part and way to make bumpers.
Yeah. And then a kind of a broad question: how do you find your limits before you start building? How do you know just what you're capable of doing as a team?
I would say the best way to find your limits is to take note of previous seasons and take note of your off season. If your team in the off season built 3 robots, probably pretty safe to say that your limits are higher than most teams. If your robot, or if your team, didn't meet it all off season, you're a rookie team, or new people, most of the 90% of the team are new people and don't really know what they're doing, your limit's probably lower. It's you can also look at past years, like if your previous year your team did really well, but 80% of the people who touched the robot graduated, your team is probably going to be less advanced than it was the year prior. Versus if your team performed, we'll say, middle of the pack, and no one graduated from your team, you can expect to be at a similar position that your team was, if not better. So it's the things leading up to the season that you can help try and project where your team is going to be into the season. Because it's better to set, and when you're doing that, it's better to kind of lowball and be better than you thought than trying to attain a goal that because you set your goals too high and then continually trying to chase and ascertain something that is out of the scope of your team.
All right. We have lots more questions, but I think we're going to wrap it up there. You can always email Teddy at the email that he's provided here. But that concludes our panel on simple solutions for FRC success. Thank you, Teddy. Be sure to tune in at the same time tomorrow to see panels on equity, diversion, and inclusion in FRC and empowering women and non-binary people in STEM.